Hello and welcome to lesson 1.1. We're going to be looking at key features of functions. I'm going to just talk to you about what we're going to talk about today. So the essential question is, how do graphs and equations reveal information about a relationship between two quantities? So again, we're talking about functions. Some vocab that we're going to look at: average rate of change, interval notation, max, min, set builder notation, and zero of a function. Those are the standards. At the end of the lesson, you will be able to interpret key features of linear, quadratic, and absolute value functions given an equation or a graph. And then the lesson overview, these are all the things we're about to do. So about 5 examples, and then a concept summary that I want you to try at the end. So it says a diver is going through ocean search and rescue training. The graph shows a relationship between her depth and the time in seconds since starting her dive. So what details can you determine about the dive from the coordinates of the point 5, -8? So that point right there. Well, at that point, if time is your x, it's been 5 seconds. And if depth is your y value, then she's 8 feet below the water. So the details I can tell are it took 5 seconds to reach 8 feet above the water. Again, as you're doing this, you can follow along with the book and type in your own answer. All right, what is the average speed of the diver in the water? As for each second that goes by, see how it's scaled 1 second is 2 blocks there. And the depth is 1 block is 1 foot. So for every 1 second, the diver goes down 2 feet. So the average rate of speed would be 2 feet per second. And how can you tell from the graph? I mean, I rise over run, right? So for every 2 feet down, it's 1 second to the right. 2 feet down, 1 second to the right. Slope of the graph. Which point on the graph shows the starting location of the diver? At time 0 is where the diver started. So the point would be, go to pair 0, 2. At time 0, diver was 2 feet above the water. And last question, communicate precisely. What does the V shape of the graph tell you about the dive? That tells me that the diver ascended at the same rate that she ascended. It doesn't tell me whether or not she hit the bottom of the ocean or she just chose to go down 8 feet and then come back up. So we don't know anything more than what's given, but I do know that she went down and up, and it was at the same rate. Okay. So when you finish a question like this, and again, this is just this is like you're taking notes. So this is not getting submitted to me. You're not getting graded on this. This is just you taking notes. So when you're done typing in your answers, just hit next. All right, notice how this example has 3 dots up here. The first, the opener, if you want to call that the Explore assignment that we just completed, there's only 1 screen for that. So that's why I hit next when I was done. For this one, notice how again there's 3 different parts to it. We're going to need to scroll through here before I would hit the next button again. Okay. What are the domain and range of the function defined by y equals x squared minus 3? All right, so this is the graph. This graph represents a function because each input has exactly one output. It also would pass a vertical line test if you were to do that. The set of all possible inputs for a relation is called the domain. All right, you can square any real number, so any number can be input for x. Also notice how the graph goes, while it's going up, it's going to the left and to the right. So this graph would cover every possible x value. So its domain is all real numbers. All right, the set of all possible outputs for a relation is called the range. The square of a real number is greater than or equal to 0. So the minimum value of y equals x squared minus 3 is 0 minus 3, or negative 3. The other way you can see the range is just by looking at the graph. Negative 3 is the bottom, and then it goes up in both directions. So negative 3 is the least it could be, but it can certainly go higher in terms of the y values, which is the range. There's 2 ways to represent range and domain. So set builder is essentially, I'm not going to read through all that, but what I want you to get out of that is set builder is an inequality, or if it's a real number, maybe it's all real numbers, then it's just all real numbers, okay? Interval notation is going to look a little bit like an ordered pair. For domain for this one, since it's all real numbers, it can go to the, basically there's 2 numbers. One is where it goes to the left, and then the other number is where it goes to the right. So in this case, for the domain, since it was all real numbers, it goes forever to the left and forever to the right. For the range at the bottom, so range is up and down. So the bottom is on the left, the top is on the right. The bottom is negative 3, the top is infinity, right? You put brackets around a number if it includes negative 3, like that graph goes through negative 3. So I would use a bracket for it. Think about that bracket as greater than or equal to. If it was an open circle there for whatever reason, then it would be a parentheses. You always put parentheses around infinity because infinity is not a number, okay? It's a direction. All right, so again, we're not hitting next yet. We're going to move over to the second part of this. All right, an air tanker flies over forest fires and drops water at a constant rate until its tank is empty. What is the domain and range of the function that represents the volume of water the air tanker can drop in x seconds? Well, if it's got 8,000 gallons in its tank and it releases water at 400 gallons per second, the function would be f of x is equal to 400x. If it can do 400 gallons per second and it's got 8,000 gallons in there, divide it, right? 8,000 divided by 400 is 20. So it would take 20 seconds for it to empty, right? The domain then would be 0 to 20 because after 20 seconds, it's going to be empty. The range in terms of how much water's in the plane would be 0 to 8,000, right? 8,000 is the maximum because that's the maximum it can hold. 0 is the minimum because you can't have less than none of it, right? You can't have a negative amount of water, okay? All right, so we're going to try same deal. What I want you to do is pause the video. I want you to try to answer it, and then when you have tried it, hit play again, and I'll answer it. So again, I'm going to give you a second to pause it here. All right, so let's go over the answers. What I would do is graph them. I would graph the function and look at it, and then that's how I'll determine the domain and range. I have a graphing calculator I can project on my screen. You also have, I mean, if you have your own graphing calculator at home, that's wonderful. If you don't, you actually have one on your Chromebook. Now, I'm not 100% sure how or where you locate that. I just know it was put on there. So it should look similar to mine. Um, I can make it look exactly like a calculator by, hold on, hitting that, and then like this, like everything I type goes in here. Like that's exactly what the calculator looks like, right? Um, what actually is a little more helpful is to blow up the actual part where the numbers are going in. So I'm going to do it that way, but it's the same. All the buttons on the calculator are in the same place. Again, you should have a program where you can use a graphing calculator on your screen. Hopefully you can find it. Let me know if you can't. It'd be a lot easier if I was in the classroom with you to figure that out. Anyway, we're going to graph that first function to be able to answer it. So y equals absolute value of x minus 4. So if you want to type in an absolute value bar, you hit the math button. You're going to have to go over to that number column. So we're going to move one to the right. See how it says ABS? That actually stands for absolute value. So I'm going to hit enter on that. And what comes up are absolute value bars I can type inside. The variable x is going to be this button here. And then it's minus 4. Make sure when it's subtraction, you're using that minus button, not that negative button. And that's it. Then you're just going to hit enter. And then graph. So what we see is the absolute value function graphed where it is. So y equals x, absolute value of x minus 4 is here. The vertex is right here. So if it's asking me for the domain, the x values can be anything, right? It's going forever this to the left, it's going forever to the right. So I'm not going to get too complicated here. I'm just going to type it in this way. Domain is all real numbers. In set builder notation, use parentheses. And then I need to use the infinity symbols. This, I'm not sure what that is. This button right here is how you're going to be able to input characters like infinity or anything else that was not like on your keyboard. So I'm going to hit that button. Let's see, where's infinity? Variables, basic. All right, so infinity is under basic, that button right there. So I want to put a negative sign first, then infinity, then a comma. I have to go hit the cursor again, and then infinity again, and that's it. Again, what that notation means is that function covers to the left infinity and to the right infinity, covers everything. For the range, again, we're talking about the y values. So I'm going to go look back at the graph. The range, right? It starts at bottom is 0, right? That's the lowest it goes, and then it goes up. It does include 0, right? So I'm going to say the range is, I'm going to use the variable button. So y under basics is where I'm going to hit greater than or equal to. I can type in 0. And then for set builder notation, I'm going to hit the bracket because it includes 0. And then type in 0, comma. And then on the right side, it's infinity. And then close it off with parentheses. Okay. And then you can check your answer also, whether you're watching my video or if you're just doing this on your own without even watching the video, you can check your answer. And that's basically what it's telling you. All right. I believe once you hit check answer, you can't then type back in for whatever reason. You can probably go like open it back up and go back. For this one, I'm gonna do the exact same thing. I'm gonna graph it. So I'm just gonna go in and hit that y equals button, clear it out. So I don't want to see the graph we just did. It's a totally separate question, right? And then it's 6x. So, whoop. All right, so I got 6, typed in 6. X, I'm going to hit that button. And then minus 2x. And then the exponent button is that button there. All right, then I'm going to hit graph. Okay, so same deal, really. I'm looking at domain. It's going forever to the left and forever to the right. So I'm just going to copy it because the domain is exactly the same as what it was before. It's not going to let me copy it, huh? All right, then I'm just going to type it in. Domain is all real numbers. And then separate orientation is going to be the infinity deal again. We'll need to go back and type a comma. All right, and then the question is, what's the top there? Once we learn about quadratics, I'm going to give you an algebraic way, to take an equation and figure out what the vertex is. That would be the point at the top. For right now, we're just looking at a graph. It's kind of hard to tell. It's like 1, 2, 3, 4, about halfway between 4 and 5. So my guess is 4.5. There's an easy way to tell. You can force the calculator to tell you exactly what that is. What you're going to do is you're going to hit the second button. And then the reason why I'm hitting that second button, by the way, if you're using a graphic calculator for the first time, when you hit the second button, it turns whatever the button is that you're about to hit into whatever the blue word is above the button. Right? So it gives the button another functionality, another function. So I'm hitting the second button, and I'm hitting that because I want to do the calc button. So I'm hitting the trace button, but I'm really getting into the calc function here. What that does is it gives me several things that I can click on. What I want to find is a maximum point. I want to find out what is the maximum height of that curve. So I'm going to hit on that. We're going to look at all these different, well, at least maybe 2, 3, 4, and 5 at some point in the near future. So we might look for a zero of a function. We'll talk about what that even means. Minimum means what you think it probably does. Intersect is going to be where you have two different graphs graphed, and we just want to know where they cross, where they intersect. But for right now, we're going to use the maximum function. You can either scroll down and hit enter, or if you didn't know this, see how everything is numbered? If I want the thing that says number 4, I can just then go and hit number 4. Okay. It's asking for a left bound. Basically, I need to put that cursor somewhere to the left of where I think the maximum value is going to be. So I'm going to move it a little bit over to the right. It doesn't have to be that close. Where I have it right there is fine. Again, it doesn't need to be exactly where I have it. I want to hit enter. Then it's asking for a right bound. So I need to move the cursor to the right of where I think it's intersecting. So I'm just going to be safe and move it well past that top point there. I hit enter. It gives me a guess. I'm going to ignore that and hit enter again. And what that does is it gives me a maximum value. It's the coordinates of that point. The x value is 1.5. I don't actually really care about that. Since we're talking about range, I care about the y value. All right. So before I said it looks like it's about 4.5. It turns out it was exactly 4.5. But the calculator confirmed that for me. Again, eventually, when we get into a unit, which is going to be unit number 2 on quadratics, I'm going to show you a way to calculate that by hand. Why is by hand better than a calculator? Well, doing this by hand actually would be faster than graphing it and doing all this typing on your calculator. So I will be giving you that eventually. We're just not there yet. So in order to answer this question, I had to use the calculator. It ends up being 4.5. So when I go back and type in the range, it's all the y values. Again, since it's opening down, it's all the y values that are going to be less than or equal to 4.5. So y, over the basics, less than or equal to, I can move this so I can actually see what I'm typing. And then 4.5. In terms of it being the set builder notation, kind of works the opposite of the last one. Since this is opening down, the first number in your set builder notation is what's happening at the bottom of the graph. In this case, it's going forever down. So that means I'm going to start with the infinity. And in this case, specifically the negative infinity. And then its top, the second number in set builder notation would be the top of that, which is positive 4.5. I'm going to put a bracket around that. And then again, I can check my answer. But there you go. And again, I don't need to put for the first part of your answer, just saying real number for domain and y is less than or equal to 4.5 is fine for the range. When we get to the practice, it'll ask you to input it in a certain way, and we'll do that. But for our purposes, for taking notes, this is fine. Okay. All right, so let's move on to now we're going to hit next. Again, we did all 3 parts of example 1, so now we're going to be able to hit next. And let's talk about example 2. So same deal. There's 3 parts to this. So I'll talk you through it, and then when we get to the you try it part, I'm going to have you pause the video, have you try it yourself, and then you can listen to my explanation. So it says a car starts a journey with a full tank of gas. The equation y equals 16 minus 0.05x relates the number of gallons of gas y left in the tank to the number of miles the car has traveled, x. What are the x and y intercepts of the graph of this equation, and what do they represent about the situation? So that is the line. The graph is a line. It has a negative slope. A negative slope seems to make sense for this situation because if it's the distance you've traveled comparing to the gas remaining in your tank, the further you travel, the less gas that is going to remain in your tank. So as you drive, you burn the gas, right? So in this case, that seems to make sense. It also makes sense that the line is only in the first quadrant, like it doesn't extend to the left and it doesn't extend down. Reason being, the initial distance traveled is 0. When you start your journey, you're at mile 0. There's no negative distance. It doesn't make sense, right? And the gas remaining in your car can't go below 0, right? You can't have negative gas in your car. That doesn't make sense. So it's going to stop at those points. The y-intercept represents the point where you start your journey. You're at 0 miles traveled and you have 16 gallons of gas in your car. Okay. The y-intercept is also that 16 that's written there. Okay. If that was in slope-intercept form, it would have come second. It doesn't matter. It's still 16. The x-intercept represents where you've traveled 320 miles and you have 0 gallons left in your car. So that's where you ran out of gas, 320 miles down the road. Okay. And again, that's just pointing out what we just talked about. All right, so again, I'm not hitting next. I'm just going over to hit the next part of this example. All right, so what are the x and y intercepts of the graph y equals absolute value of x minus 3? I'm going to graph it. Right, that's the easiest thing to do. Actually, no. You know what I'm going to do instead? Let's talk about how to find x and y intercepts by hand. Again, you could graph this, and that's fine. Let's do it by hand because this is something you don't need something new to do. You should be able to do this. So for the x-intercept, it's where y is 0. So 0 is equal to absolute value of x minus 3. Now I'm just going to solve that for x. So what I'm going to do is I'm going to add 3 to both sides. And you get 3 is equal to the absolute value of x. I'm going to flip that around so I have the x on the left side. And I don't know if you remember this when you solved absolute value equations in Algebra 1. First, you assume what's inside is positive. If the x inside is positive, the absolute value of a positive number is itself. So then x is equal to 3. If you assume what's inside is negative, that means the absolute value of a negative number is its opposite. So you're going to get that x is equal to negative 3. Okay. So in this case, you have two x-intercepts. Your two x-intercepts are 3 or negative 3. All right, let's do the same thing for the y-intercept. The y-intercept is where x is 0. So if x is 0, then y is equal to the absolute value of 0 minus 3. Absolute value of 0 is 0, so that's gone. So that means then y is equal to 3. So your y-intercept is at 3, only 1. All right, and then when we find out the intercepts, same deal. The x-intercepts are plus or minus 3. That's what we figured out. The x-intercepts are also called the zeros of the function because they are the input values that result in a function output value of 0. They also, again, are the x-intercepts. They're where they cross the x-origin on the graph. So that's how you'll be able to find them if you just were looking at a graph. And then to find the y-intercept algebraically, again, what we just did. And the y-intercept is at negative 3. Okay, so let's just do the third part. All right, so what are the x and y intercepts of g of x is equal to 4 minus x squared? Same deal. I'm going to change this to y equals, because that's what g of x actually is. It's just your y value in function notation. Okay, let's find the y-intercept first. The y-intercept is where x is 0. So now the y-intercept can be found where y is equal to 4 minus 0 squared. 0 squared is 0, so y is equal to 4. So the y-intercept is at 4. The x-intercept is where y is 0. So it's 0 equal to 4 minus x squared. So I'm solving that for x. I'm going to add x squared to both sides. You get x squared is equal to 4. I'm going to take a square root of both sides, and I get x is equal to plus or minus 2. Again, square root of 4 is 2 or negative 2. So those are my intercepts. I'm going to go ahead and type that in. I guess it asked for x-intercept first, so I'm going to do that first. So x-intercept that's right, 2 4, and -2 and 2. And the y-intercept is 4. All right, and they gave them as ordered pairs. Probably a better way to do it. Again, when we do the practice in a couple days, I'm sure it'll be asking you to input it as an ordered pair. So just make sure you're doing that. Okay. Um, all right. So at this point, we are going to pause. Again, we got through the first two examples. Um, I want you to again have tried each of the examples and so on. Um, Tomorrow, we will finish the lesson. Okay, and then Wednesday we will start the practice. Okay, and reach out if you have any questions. But at this point, I just want you following along and filling out the textbook as you go. All right. Again, reach out if you have any questions.